Right now, the ground beneath our feet is cracking. But if you look at the sky above those arid landscapes, a massive contradiction is rolling right over us. Up in the atmosphere, billions of gallons of unmapped moisture drift entirely unused over our most drought-stricken coastlines. This is ghost water, a floating ocean suspended directly above failing surface infrastructure. The 2026 Q1 Drought Index records an 85% depletion in Western underground water reserves. We are draining aquifers faster than they replenish. Furthermore, the National Water Census shows a critical 40% drop in surface reservoir baselines since last spring. The standard institutional response is to build centralized, energy-intensive desalination plants. But under current climate extremes, these systems are expensive to run, fragile, and prone to mechanical failure. We cannot solve structural depletion by digging deeper into dry soil. The math requires a directional shift. We have to look upward at the atmospheric resources already in transit. We can intercept this ghost water by deploying decentralized high-tension mesh arrays. These specialized nets strip moisture from coastal mist, condensing ephemeral fog into an immediate, localized water supply. Securing off-grid infrastructure means stepping away from fragile centralized pipelines entirely. It requires learning to harvest the sky to establish absolute resource autonomy. To replace the failing modern grid, we look backward to ancestral engineering. The mechanics of atmospheric condensation have operated in the natural world long before industrial pipelines existed. In one of the harshest climates on Earth, the Namib Desert beetle survives by catching morning fog. It uses its physical structure to force ambient moisture to coalesce on its textured shell and slide downward as drinkable water. The beetle expends no energy to accomplish this. The collection process relies entirely on passive surface interactions. Human history eventually adopted this biological mechanism. Ancient cultures living in the Atacama Desert applied the exact same logic to their arid surroundings. They constructed specific stone piles that functioned as primitive catch nets. By utilizing the passive thermal mass of the stones, they forced the ambient coastal fog to condense directly onto the rock surfaces. Both the beetle's shell and the Atacama stone piles operate on the basic laws of thermodynamics. They exploit physical temperature differentials to force atmospheric vapor to phase change into a liquid. The objective for 2026 takes that proven survival mechanism and upgrades it with modern materials, projecting self-sufficiency into new vertical dimensions. Harvesting fog relies on proven zero-energy physics. We are simply scaling up a thermodynamic process to meet modern human demand. A functional array requires precise macro engineering. The mesh panels must be tension-mounted directly perpendicular to the prevailing coastal wind currents to maximize the volume of air passing through. Early engineers used traditional nylon nets for this. Nylon fails to capture enough volume to sustain a household. The physics were sound, but the material was highly inefficient. This schematic shows the microscopic geometric lattice of a graphene-exene mesh fiber. Woven directly into these nodes is a super hydrophilic surface pattern. The nodes heavily attract ambient moisture, forcing microdroplets to rapidly accumulate, aggressively merge, and coalesce into much heavier bodies of water. This data visualization charts the total collection volume between the two materials. The graphene M-axene weave yields a 400% higher collection efficiency than the standard nylon. That leap in capture efficiency pushes the technology past a novelty. It produces enough sheer volume to make the array a viable replacement for an industrial pipeline. By applying advanced nanomaterials to a basic net, passive biomimicry scales into an aggressive, high-yield atmospheric sponge. Getting water onto the net is only half the equation. The primary failure point of coastal fog harvesting is high-velocity wind, which frequently blows captured water right back out of the mesh before it falls into the collection basin. To solve this, the structural supports and runoff channels of the array are treated with specialized hydrophobic nano-coatings. This simulation demonstrates how these coatings act on the coalesced water. While a droplet clings to standard nylon under wind pressure, the nano-coated surface forces the droplet to shed 30% faster, instantly sliding off into the channel. Because the shedding process is accelerated, the water drops cleanly downward before the coastal wind has the opportunity to rip it away from the structure. This rapid shedding enables a strict zero-energy design. The system uses the surrounding topography and the gravity pulling those heavy droplets downward to create a naturally pressurized delivery mechanism. By pairing nano-coatings with gravity, the array requires no pumps and zero grid electricity. You extract all mechanical failure points from your water supply line. When we apply these microscopic fluid dynamics to a real-world macro environment, the residential potential is immediate. A strategically placed multi-panel residential array intercepts and condenses enough daily potable yield to easily surpass standard household consumption. The flow path operates continuously. Moisture condenses on the mesh, drops rapidly down the gravity channels, and ends up pouring directly into sterile collection cisterns. Beyond household use, there is a measurable ecological benefit. Surplus moisture runoff naturally overflows from the arrays and seeps into the parched earth, restoring native flora around the base of the nets. The technology transforms a dry piece of property from a grid-dependent liability into a self-sustaining micro-oasis that actively heals its immediate environment. State-managed utilities are becoming increasingly expensive, rationed, and unreliable. In contrast, the atmosphere provides a vastly abundant renewable reservoir. While corporate entities heavily monopolize groundwater rights and pipeline distribution, atmospheric rivers exist in a legal blind spot. Air rights remain unowned and entirely unregulated. A localized mesh farm legally bypasses that corporate chokehold. You disconnect from the metered grid to establish an independent supply line, free from state mandates. Subscribe to Unearth the History for more deep dives into the forgotten technologies and forbidden ancestral engineering that secure your true independence. Hit the like button and share this blueprint with others who are ready to take control of their resources. Community resilience does not come from waiting on state bailouts or billion-dollar infrastructure projects. The water is already here. You just need the knowledge and the net to catch the sky.